It's measures of center and variability, and then transformations of data. So we're going to learn how in our calculator to calculate the average, so the mean, the median, which is your center point, the mode, which is the number that occurs the most often, the range, which is your max minus your min, and then also we're going to find how to calculate the standard deviation just from our calculator. So standard deviation is something new that you may not have seen before. All that means is so let's say that you take the SAT, they put all of your scores on a standardized curve, which we would call a normal curve, and it looks something like this, like a bell shape. And it's on a standardized curve because in the middle is your median, that's your 50th percentile. So when you get your scores back, they'll tell you what percentile that you're in. So let's say that you're in the 75th percentile. That means that you're 25% above the middle person and that you're 75% above everyone else. So 75% are below you, 25% are above you. And so in order to get that percentile, they have to calculate a standard deviation, which is the average distance from the mean. So think about being the distance from your mean. So your median and your mean are in the center. A standard deviation is just an average distance. And if you take AP Stats with me, then you'll learn that there are about 3 standard deviations on each side. So if you go out 3 standard deviations above and 3 standard deviations below, then that takes up like 99.7% of everyone in whatever you're measuring. So everyone that took the ACT on Saturday, if they calculate a standard deviation, let's say that the middle score was, I don't know, what's a good middle score? Like 25, 26? A good middle score? So let's say that the middle score was, let's say that it was 26. And I calculate a standard deviation, and that number is 3. So that means that let's say that it's 2. So if my standard deviation is 2, and that's a lowercase sigma, that's how you would denote that. If it were 2, then I would go out 2, so 28, 30, 32, and 24, 22, 20. That means like almost 100% of the people that took the ACT scored between a 20 and a 32. So that's probably not a real life, it's kind of a real life example, but it was a really good day at the ACT. So we're going to learn how to put these into our calculator, how to put data. So if you have a TI Inspire, I want you to go to the Add Lists and Spreadsheets in your calculator. The Add Lists and Spreadsheets. Kind of how we did that linear regression. Make sure that nothing is in your calculator in the list or the spreadsheet. If you have a bunch of tabs open, you may want to scroll to the top right-hand corner and hit the X button. And if you hit that X button, do you want to save? Hit no, I don't want to save. And then you start over. So if you have everything cleared out, you're going to scroll up to where it says A, and you'll just type in, I'm going to type in X, my list X. Hit enter. And so once you do that, I'm going to type in Office A data. So I'm going to start at number 1, and I'm going to type in 14, 17, 18, 19, 20, 24, 24, 30, 32. If you have a TI 84, then you're going to go to Stat, Edit, Stat, Edit, and then you're going to type in your data into list 1. So Stat, Edit, and then type your data into list 1. So whenever you're typing it into an 84 or an Inspire, make sure that your top of your list says X, or you could put anything there, and then you type in your data. That's on Add Lists and Spreadsheets. Then you're going to go to, for your Inspire, once you have that typed in, you're going to go to Menu, Statistics, so option 4. Then Stat Calculations, so that's option 1, Stat Calculations. Then you're going to choose the 1 variable statistics, so it's option number 1, 1 variable statistics. Number of lists, you're going to say 1. Then you're going to change your X list. It should say have like B and then some parentheses or something, brackets. Hit the right button and then scroll down to where it says like an apostrophe and then X. Then you'll just hit tab all the way down. Frequency list should say 1. Nothing for category list. Leave everything else blank and then hit OK. Yeah, just leave that. Then leave that as, and then hit OK. And I'm going to write down everything that I have. So my X bar, if you scroll up to the top, so it says title. My X bar is my mean or my average. So I'm going to put mean. So same thing as X bar. And that would be 22. Median, if I scroll down, it gives my minimum, my Q1, my median. My median is what? What is my median for this set of data? 20? Yes. Go to stat. Oh yeah, so if you have an 84, you'll go to stat, to the stat button, then calc. So scroll to the right to calc. And then choose the 1 var stats option. 1 var stats. Then it should already have list 1 there for you. So you just hit calculator, hit enter, and then it'll give you all of the data. So my median for this was 20. Is that what you guys got?
Where did you get that?
I kept scrolling down. So at the top it has X bar. Then it says sigma of X, which is just like adding all of your X's together. You don't need any of that. Then it gives me N, which is my sample size. Minimum, 14. Q1.
How'd you know that?
Median is 20. And then max. So you just scroll down to where it says median. Did y'all find that?
Yes.
And median is going to be 20. My mode, I can just look at the data and tell which one occurs most often, which is which one? 24. My range, I take the max minus the min. It gives me the max in my calculator, which is 32. And it gives me the min, which is 14. So my range is what? $18. And then my standard deviation, we're going to use this symbol, which is a lowercase s in Greek, called sigma. Kind of looks like a little curly O, kind of. And in the calculator, it has that symbol for you where it says sigma of x equals, and then it's the number that says 5.676. So if I wanted to just change my data really quickly without having to do stat calculations all over again, if I scroll to the left to my original list and I type over that data, this is for an Inspire. If I type over that data, so I'm going to go to number 1 where it says 14 and I'm going to put 8, 11, 12, 16, 18, 18, 18, 20, 23. So all I did is I rewrote over the data. It changes everything for you automatically. So if you go back to the right where the stat calculations are, everything is already changed. Like it kind of like refreshes every time that you add new things to the list. No, we're not going to do Office B. I just wanted to show you what to do. Okay, number 2, it gives us the data now in a graph form. You see this a lot on the SAT. so what we would want to do is calculate the average number of colleges applied to per student. So to find the average, you just take the number of colleges. You're going to put the total number of colleges over the total number of students. So it'd be like taking all of your test grades, adding them up, and then dividing by 24, or however many students that I have. So how many colleges did Jill apply to? 6. And then Sarah was 3. Tom was 0. Tom's not going to college. Sam is 1.
That's me, dude.
Tom is a famous artist and he does not need to go to college. And then Noah, Tom's going to go pursue his music career. Noah is 7.
How'd you know? I wanted to be a rapper since I was 12.
And then how many students do I have? 1, 2, 3, 4, 5. So I'm going to plug this in my calculator. You can't put this in a list or anything.
They
And
call
you
me 23 Savage.
put that in your calculator, and what do you get?
17 divided by 5.
17 divided by 5, which is, what is the decimal? 3.4. Does it make sense to apply to 3.4 colleges? No, but even though it's an average, you still keep it as a decimal, so do not round. Don't round. Leave it as 3.4. It's kind of like the average number of kids that families have in the United States is 1.2. That's a real statistic. You can't have 0.2 children, but finding the average, you end up getting a decimal.
How are you going to have a point two?
What if you have like 19 kids and you're still counting? And so you have like 19.2.
Do not know. Okay, what I want you to do with number 4, I want you to type that into a list. Type number 4 into the list. Okay, yeah, so let's go back to number 3 really quickly. It says, what is the range of colleges? Noah had the most colleges applied to, that was what? So my max is 7. And my min, what was the least number applied to? 0, so my range is one number. Do not say that it is from 0 to 7. It is not, your range is not 2 numbers, it is one number. It is 7 minus 0, which is 7. So my range would be 7. So remember that. You might want to make yourself a note. Range is only one number, not 2. All right, so with number 4, when you rewrote over all of your data in your first list, it calculated everything for us. So for part A, my mean was what? What was my mean in this set of data? 14. My median? My median is 14.5. My mode, I have to just look at the data and see. 15. My range, max minus min. So 17 minus 11, which is 6.
What if no numbers repeat? What would the mode be?
You would say none. And then my standard deviation, which we call sigma, or you can put SD. It is 1.673. Okay, then part B, it says the winning score in the next games is an outlier, 3. So let's say that I added 3 to the data. So let's go over to the first list. And in cell number 11, I'm going to add 3. So I'm adding one more score. Now I'll have 11 games. So for part B, now I want to see how the mean, median, and mode change. So when I added 3 to the data, what happened to my mean? It is now what? 13.
Oh, yeah, sorry.
My median is now 14. My mode is still 15. My range 17 minus 3, which is 14. And then my standard deviation is 3.54. Yes. You add like another data point. So let's say I have another winning game, and then now I have 11 games. So then I'm putting 3 as another data point. Be like adding a new student. I have another test grade to factor in. So what changes the most? If we look at part C, what changes the most out of these? And so, but it says what measure of central tendency. So out of central tendency, that is either mean or median. Central tendency is like your center.
So the mean changed the most because it changed the whole point.
Yeah, so the mean changed the most because it changed a whole point. Because remember, median is like your middle. And by adding a data point on the outside, that doesn't really affect it that much because I still have my middle point. But my mean, it's like when somebody makes a really, really high score on a test and that throws the average off and it makes everyone mad because now there's no curve. It's kind of like everybody kind of scored in the 70s range, but then you have that one kid that made a 105 and you're so mad. So the mean was affected the most.
Yeah, everyone get a 20 on the next test.
No. Unlike you, I cannot drop my grade like that.
Okay, so once you have typed all of those test scores in, we are going to find the mean, median, mode, range, standard deviation, and then we're going to talk about how data is transformed. So original, this is my test scores for 5th period. So if I look at my average, what was my average? What was my mean? 85.64. What is my median? 86.5. What is my mode? 84 occurs the most often. My range is 100 minus 63, so 37. And then my standard deviation is what? 9.17 about. So remember me talking about like if this were a standardized curve, how if I were in my center, so 86.5 was in the middle, like almost 100% of the people would score 9.17 times 3. So 9 times 3 is 27. So 100% are within 27 points of the median. That's just a fun fact. You don't have to memorize that or anything, but it's just kind of fun to think about. So the standard deviation, so if this were on like a normal curve, this is just a preview of AP stats. You have your median in the middle, which is 86.5. If you go out 3 standard deviations to the right and the left, that contains like almost a 99.7% of the people that took the test. So if 9.17 times 3 is about 27 points. So if you take 81 or 86.5 minus 27,
About the difference between each.
59.5, and then 86.5 plus 27, 113.5. About 99.7% of everyone scored between a 60 and 113. That's just a fun fact, but you don't have to have that memorized. I just think it's really interesting. So, yes.
About the median, how to be like one of the data points?
No, median is your center point. So since I have, how many data points do I have? I think I have an odd number. So when you have an odd number, you take the average of the middle too. If it's even, then you take the average of the middle too. If it's odd, then you just take the center point. Yeah, exactly.
Even if it's not like exactly the center.
Okay, so now it says, let's say that Miss Thornhill is a generous person, because we all know that I am, right? And I'm going to give everyone a 5-point curve. So now I'm going to give everyone a 5-point curve. So if I give everyone a 5-point curve, I'm going to go back to my list. And I'm going to add 5 points to everyone's data. So go ahead and do that. Add 5 points to everyone's list or to everyone's data set. You can just do it one cell at a time. There's a way that you can make a new list and then just add 5 to every data point through like it kind of like an Excel spreadsheet and not equal sign, but I think I don't want to confuse, so I'm just gonna keep. Okay, so once you have given everyone a 5-point curve, so the first person that had a 63 would make a 68, 77, 80, 84, 89, 89. So what is my new mean? What is my new mean? 90.64. What is my new median? 91.5. What is my new mode? My new range? It's still 37. My new standard deviation? 9.17. Interesting. So let's talk about what happened. What happened to my mean, median, and mode? What? They all added plus 5. What happened to my range and my standard deviation? The same. So let's think about that. Why did that happen? If I have my data and it looks something like this, so here's my distribution of scores. It looks like a little bell curve. And let's say that I give everyone a 5-point curve. That's just shifting this over to be 5 plus 5 points. So like the width of my data did not change. It truly took everyone's data and just moved it over on a number line plus 5 points. So my range did not change, like my max and my min, the difference between them did not change. And the standard deviation, like the width, does not change. Yes? Mm-hmm. Okay, so now the next part, it says, let's say that Miss Thornhill is an even more generous person, and I'm going to give everyone a 10% curve. That would never happen, but hypothetically speaking. So now let's take the data. Let's go back to the original data. So type in the original. So go back and type in the original. And then how could I give everyone a 10% curve? What would I need to multiply each point by? 1.1. 1.1 because I'm adding 10%. So type in your original data again, and then take every data point and multiply it by 1.1. That's giving everybody. You can just times it in the thing. Yeah. Okay, once you plug that in, what do you get for your mean? 94.21. And what about my median? 95.15. What about your mode? What number occurs the most often in your list? $92.4. My range is now what? So my max minus my min. What is my maximum point? 100 times 1.1. So you were supposed to take all of your data and multiply it by 1.1.
That's 110.
110 minus.
It'd be 39.6.
What was your smallest point?
64.1.1.
63 point what? Or what is 63 times 1.1?
It's 69.3.
69.3. So you end up getting 40.7. Then my standard deviation is what? 10.09. So now we compare to the original data. Did everything change this time?
Yes.
Yes, it all changed. And what did it all change by? How much percent? 10%. So this increased 10%. And the range and standard deviation also increased 10%. So why did they both change this time, do you think?
9% instead of just adding points.
Because it's a percentage. So like your percentage for 100 is 10% of 100 is more than 10% of 60. So that person that had that got 100 gets 10 points. Why does that seem fair? That's why we don't really do percentage curves. Yes.
So couldn't we like just added 10% to the mean, median, and mode and like?
Yes. You
You
could.
just added plus 10%.
You could have. Yes, exactly. But I wanted you to discover that knowledge, you know. Okay, last thing. So everything changed when you multiply by a percent. So some rules to think about is when you add. So when you add things, only the mean, median, mode change. So make yourself a little note of that. When you add, only mean, median, and mode change. But then when you multiply by a percentage, or you divide by a percentage, then everything changes. When you multiply. Okay, now let's say that Brendan took their test late, or we could say Brooks. Let's say Brooks. I think that's funny. Let's say that Brooks took their test late because they were absent and then scored a 27. So let's add a 27 to our data point. Go back and put your original data in. It doesn't take forever.
Say that I took my
So original data, then in blank number 15, you're going to add a 27. Okay, so whenever I added in this 27, we call that an outlier because it's not like the others. Then what happened to my data set? What happened to my mean? It dropped. It went to what? 81.73. What happened to my median? 86. My mode, it stayed the same. My range, what happened to my range? It went up. And my standard deviation, what happened to that? 17.1. Wow. So a lot of things changed when I added that outlier. So most predominantly what changed was my mean, my range, and my standard deviation. My median, it changed a little bit, but that's only because I added in one data set. So my median didn't change significantly, so I do not count that. So my mean decreased, and then my range and my standard deviation increased. Because if you think about this data, here's my little bell curve. I add in this 27 out here. That now makes my range wider. It makes my width wider. And then it pulls my mean away from what it was. So it brings the average down.
So median and mode aren't really affected.
So median and mode are not affected. Correct. So then lastly it says, which measures are resistant or not affected by outliers? We would put median and mode in that. Median and mode are not affected. So now we're going to learn how to calculate what you need to make on the test to make an A in the class. I did this in college all the time for my friends that wanted to know what they needed to make on the final. You could start like charging money for that, and I promise you would make a lot because...
Great calculator online for that.
Well, that's dumb. You should calculate it by hand. Okay, number 5. A college used a weighted average to calculate a student's GPA. Letter grades are converted to number as follows. So an A is 4, B is 3, C is 2, D is 1, F is 0. And then the weight is the number of credits. So determine the student's GPA for the semester. So in order to do that, I'm going to take the total number of credits, including the grade. So I'm going to take the grade and the credits divided by the number of credits that are possible. So in physics, it's worth 3 credits, and they made a B. So for my numerator, I would take 3 times 3. In calculus, 4 credits, and I made an A. So 4 times 4. In English comp, I made In a C, so how many credits is a C worth? 2, and then that's 3 credits. In physics, I did not do so well. I got I got a D, so that's 1 times 1. And then computer programming, did well, 3 credits, and I got an A, so 3 times 4.
Wait, I thought it was 4 times 3.
Or 4 times 3, either way. Whichever way you want to think about doing it. It's the same thing. 4 times 3, 3 times 4. I can write it as 4 times 3 if that makes you feel better.
No, it's okay.
All right, then I'm going to put that over the number of credits. So I'm going to add the 3 plus 4 plus 3 plus 1 plus 3.
That was some quick math, actually.
14.
So you end up getting, what do you get for your numerator? What do you get for your numerator? 44 over 14. And then that would be, what would your GPA be when you type that in? What decimal?
So 3.5.
3.14 pi.
No way.
Woo.
High, you're no.
Yes, that's a good GPA right there.
That is awful.
Yes,
Okay, that's not.
it is when it's pi.
I'm not going to allocate because I'll probably end up with that.
Okay, so whenever the grades were switched, like A and B, physics and calculus, these two changed. So now you have 4 times 3, because in A and physics, 3 credits, grade of A, and then calculus 4 credits, but a grade of B, so 3 times 4. So that would be your new GPA. So in a class, 18 students had an average midterm exam grade of 85, and the 12 remaining students had an average of 90. So 18 had an 85, 12 had a 90. What is the average for the exam grade of an entire class? Do not put 87.5. Do not put that. It is not 87.5. Because why? Why is it not 87.5? Because more people made an 85 than made a 90. So when you average in that total, it's going to be pulled more towards the 85 than it is the 90, because more people made a lower grade than a 90. So a way to find that would be like the total number of points divided by the number of students. So to find the total number of points, I'm going to take 18 times 85 plus 12 times 90, and that gives me total points. Like out of 30 people, if I added all of their points together, they had 1,500 points. And then I'm going to divide that by the number of people. There are how many people total? 30. When you type that in your calculator, what do you end up getting? 87, which is closer to 85 than it is 90.